The following content has been provided by RWTH Aachen University.
All right, welcome to iOS application development, the fourth lecture. I'm Philipp Wacker. I will be standing in for Professor Borchers today, and it's my first in-person lecture since over 2 years, so let's see how that goes. First of all, a small recap from what you've done last week. First, you went a little bit through strings, how to set them up, and going over some main functions, how you can interact with strings, compare them, or check whether they're empty or not. Before moving over to functions. And yeah, functions like any other programming language, you know quite well how to set them up. What was something that was a little bit more specific to the parameters that you defined for the functions? Do you remember what was maybe a little bit peculiar about that? Yes?
You give a name for the for the outside, so that when you call them, you know what is what, and you don't have to go to the base method and look what it actually does.
Yes, exactly. So that there are different names you can give to your parameter that you're passing over. There's one name that is used inside the function. So if you only use one value to identify your function, that's both used outside of the function when you're calling it, and also inside the function. But you can also give what they call an argument label, specifying that this function should be called from the outside with a specific set of names, and then inside they have different ones. So the example, I think, was that you can say hello to one person and another person to another person, and you would call it outside from say hello to person and the other person, and inside you have your specific parameters that you can identify the different persons there. Okay, you also spoke about structs, and for the structs that you have the automatic initializers. If you don't specify anything, then you have the member-wise initializer that for each property or parameter in the struct, you can set that up directly. And you also spoke about functions and mutating functions. What is the difference here? Yes?
Only the mutating functions can change the property values?
Mm-hmm. Yes, yeah. So for a struct, normally a function, you can't change within the function the properties of the struct. But if you use the keyword mutating, then it also allows you to change the values of your properties there. Speaking about properties, you also mentioned computed properties and property observers. What were those about? Someone else? I will pick one if you hear. Do you remember what those were about?
No, pick someone else, please.
Okay. And let's go through the line. Oh, no, yeah, there you have volunteer. Yes.
I'm not 100% sure, but I think it was when you have like a variable and you don't set it, but you directly use it and, I don't know, calculate something.
Calculate something is right. So if you have a computed property, that is something where when you're calling that property, it's not that there's value directly stored in that, but when you access it, then it calculates what it is returning. So the example I think there was for temperature, that your struct only has a property that's storing the Celsius value, and if I access the Fahrenheit value, then it is calculated on the fly what this property is. And that prevents that you have to write specific functions that if I set the Celsius value, then I also need to update my Fahrenheit value so that everything is in sync. But instead you can say, okay, this is the ground truth for my struct, and if I access the Kelvin or whatever, then I can compute it directly from the state of the struct at that point. So that is computed properties. Property observers. Yes?
We have methods which, when we write to the property, we have before and after, so we can do things before the property is actually set and after the property is actually set.
Yes. So often then did set and was set, no, will set and did set, that's the way, is then called when I'm interacting with the property. So for example, what I mentioned with the computed property, that once I set the Celsius value, I also need to update my Fahrenheit value. I could also do that with a property observer that I know, okay, if that variable is set, then I update the others. So that can help there. So, and then also, structs are one type of where you can create your own elements in Swift. Classes are another. What is the main difference between those two? Yes. Yes, exactly. So structs are, that is really my object. So if I have a variable pointing or having that set to that struct, that is set in there. While for classes, it's a pointer to that object. So and that is something to keep in mind when interacting with the objects and elements you get in Swift, that when you pass them around, whether it's a copy you're working with or it's a pointer, so you're actually working on the same object. And that gets a little bit more tricky, or maybe it's not something that's immediately obvious if you talk about the collections. I think there you talked about arrays and dictionaries, and those are structs. So when you pass over an array to a function or whatever, you're working then within the function with a copy of that. So it's always then important, if I return that I store it again. Otherwise, it's not like in other languages. I can, inside a function, manipulate the array, and it will also be outside of the function then changed because it's not a pointer that I'm working with. All right, so much for the recap. Today, we're talking about optionals and what is the concept there, the general idea, and what can we do with them and why is that helpful? So first, in Swift, you can't really set a variable to nil. So you always need to have a value in there. So for example here, if we have our struct that is a book, and a book has a name and the year in which it was published. So for example, for the first two Harry Potter books, I can set the name and the publication year because that book has been published and I have those dates available and those years available. But if we have then a book that is just currently being written, should already been entered into the library, but it is not, doesn't have a publication date yet. So what do we do in that case? Since I need to specify an integer for that, what should I do? If we just add 0, we can do that, but it's not really, it doesn't really make sense because if we have a book that is 2,000 years old, how do we differentiate that from a book that hasn't been published? And we also need to keep that in mind, 0 is our placeholder for something that hasn't been published yet. What we would like to have is that we can actually say, okay, the publication year is not set at the point, hasn't been published, or whatever, that we can specify this is not set at this point yet. And that is where we run into the problem. Because since Swift keeps so much focus on type safety, you can't set a variable to nil. So that way you can always be sure, if I have a string, there is a string in there. Or if I have an integer, that is really an integer. It's not something that can be nil or I need to be aware of at that point. But to get around that, to offer the option that you can set it to nil, that is where optionals come in. And optionals essentially have two states. They either have a element of that specific type in there, or they're set to nil. So an optional is, or you can specify that by having this question mark behind it. So string question mark is a string optional. That is its type. String is one type, string optional is a completely different type. And so the question mark signifies, yeah, this is an optional. An optional we can set to nil. That works totally fine. Or we can put a string in there. I can't put a number in there, so I can't put an integer in there. That would not work. And it would also not default to being nil. It would just say, yeah, no, that definitely can't work. So the question mark is something you really often will also encounter when using Swift. That is something that pops up every now and then. So really, yeah, question mark means that it is an optional. And so what we can now do for our book is to specify that the publication year is an integer optional. So it can be set to nil, or we enter the year of the publication. So, but now, since it is an optional or optional integer in this case, how do we work with that? For that to be aware of, again, your system is Swift is very type safe. So if you have an optional integer that you're working with, it is a different behavior than working directly with an integer. And what that means is you need to unwrap the optional if you actually want to work with the value that is inside of it. So for the publication year, for example, if we want to really use the year that is stored in the publication year, then we need to unwrap it, and the operator for that is the exclamation point. So really that specifies this publication year, there is an integer value in there. I want to work with that value that is in there. So, but that is problematic because if there's the publication year is set to nil, this will crash in your code. So the force unwrapping only works if you're really sure that there is an integer in your optional, and that allows you to access that. So what you then most often do is, okay, you check before you're unwrapping your optionals. So the verbose way is I'm checking whether the publication year is set to nil, and if it's not set to nil, then I set the actual year that is in there to the unwrapped publication year, or I'm unwrapping the publication year and assigning that. And then I can print out the actual year. So that totally works, is a valid way to do that. But since it's so common in Swift that you're using that, there's a shorter version that you will use a lot, and that is with this if-let syntax. So you specify if-let the actual year is set to the publication year. Notice you don't need the exclamation point here. And then print out the actual year, or if that doesn't work, then do something else. So with this structure, you're trying in the if part here to assign to the actual year the unwrapped version of the publication year, or the unwrapped value from the publication year. And if that works, then we're going into the first bracket, and otherwise, we do something else with that. And that is something, you will see everywhere in Swift. So, but that also leads to a couple interesting scenarios where something are maybe not that obvious as they could be. So, for example, here we have our optional integer for the publication year, and we also have a constant for the actual year that's set to 2022. Now we have here our if-let clause with the actual year, setting that to the publication year and trying to print out the actual year, both inside the brackets and outside of the brackets. First question for that, do you think that will work? Yes?
No, because we can't make the that statement. The assignment is an optional, is an optional.
So you mean because this is already set to not being an optional? Okay. Also, could be a problem. Could also be a problem because this is a let constant. So actually, we should not be able to reset that. But this is a case. This actually works. This does compile, even though they are using the same the same value there or the same name there. But then the question also, what is the output? What will be printed out here and what will be printed out here?
We define a local variable which overrides the global, but only in this context, meaning in the if it's the publication year, but outside it's still the initially defined actual year.
So what will be the output here?
2014.
And here?
And 2022.
Yes, exactly. So that is, or the term for that is shadowing of variables, that I can, within this if-let statement or context, I can reuse the variable names and actually have here another constant that is only defined within this space. Of course, horrible way to name your variables at this point. Just an interesting thing to notice that it works. Something where that is actually often used is that you use the same names. So we could have here if-let publication year equals publication year. And what that means is I'm trying to unwrap the optional that I have outside, assign it to the internal publication year that I'm newly defining here, and then I can work with the unwrapped version. So if you have a variable name that is really on point, you need to use it in both contexts outside for the optional and when I'm working with the unwrapped version, that is something you can do there. So for optionals, there are also a couple of handy features that you can use to make the interaction with that simpler. And one is if I'm working with multiple optionals, of course, I can do that step by step, have if-let clause for the year, and then for the book edition, if that is the edition is also an optional, and then print out the year and the book edition since they're now both set to the values inside those optionals. But I can also do that in one go. So I have an if-let clause trying to set the actual year and also the book edition in one go. And if both optionals have a value stored in them, I can go into the inside of those brackets and I can print them out. If either one of those fails, the whole if clause there is evaluating to false, and I won't be trying to print or won't be able to print it out. Optionals, often also used in functions that you have a return value, that your return value is an optional, so that from within the function you can also return nil if something was not working, and also for your initializers. For the initializer, it's actually a question mark then after the init keyword. That is failable initializer, meaning if I try to set up a new struct or new class object, that can also be nil because it doesn't work or the parameters that are passed over are wrong or no network connection, whatever. That can also then return an optional. All right, so yes?
Regarding unwrapping multiple options,
Yeah.
can I also unwrap a tuple of unsafe or optional values into a tuple?
In one go, I think should work as well. You can definitely do it step by step there as well. I think it should work. Must say I'm not entirely sure. I think it should be the same, that I have my new value same as the tuple, but now without the optional values in that. Should work the same. But yeah, haven't done so recently, so I'm not entirely sure. All right. Another thing that's quite handy is optional chaining. So here we have a person. Person has an age and a residence that is an optional because maybe that person doesn't have a permanent residence, living on the street probably. And the residence has an optional address. So yeah, maybe a tent somewhere that doesn't have an address. And an address has a building number, street name, and if it's apartment, maybe an apartment number. So there are quite a lot of optionals that if I have a person and I want to know the apartment number, that I need to traverse here. So if I would do that step by step, I would first try to get assign the residence to the optional, then trying to get the address, then trying to get the apartment number. And if that all works, then I can say he or she lives in that apartment. Of course, that's quite hard to read. So what optional chaining means and how that can help you is that you have directly all the optionals chained behind each other. So that for the person, or I'm trying to assign the apartment number directly to the residence, an address, and the apartment number of the person. So in the question marks again show, okay, this is something where it could fail. This could be something that is not set. And if either of those are nil, then this whole assignment doesn't work and I won't be able to print that out. But if everything works, this exactly is the same as that one. So making it quite easier to work with optionals that are nested in each other. All right, so far about optionals on this level. Any questions so far? Perfect. So then we move over to typecasting and inspection. So typecasting, yes, how do I assign or specify that an object that I get is of a different type? In this case, makes sense if that type works and exists. So in this example, we have a class vehicle and a car that inherits from vehicle, and motorcycle also inherits from vehicle, and we have a function that's returning all vehicles from somewhere that we have, and I get back an array of vehicles. So that is the setup that we have. Now, if I want to iterate over all the vehicles that we have returned, I want to do something with the cars, I want to do something with the motorcycles. How do I do that? And similar to the optionals, I have the as question mark keyword that's then specifying, okay, I'm trying to cast this variable to this type, or if that type variable is of that type as well. And similar to the optionals, I'm trying to assign that with the if-let statement. So I'm trying to specify the car is a vehicle, and I'm trying to cast this as a car. And if that works, then I can work here with the car variable or car property and use all the functions and whatever that a car has. And if that doesn't work, I'm trying to cast it as a motorcycle. So trying to use the vehicle as a motorcycle. And so the as question mark also mentions here, this is something that might work. Then what I get back is of that type. And if it doesn't work, then I get nil back. So the return, so to say, of this action is also an optional that either works as a type or doesn't. Similar to the force unwrapping that we have for optionals, there's also the force casting. So if I have a function that returns all vehicles from a specific manufacturer, and I'm trying to, I know every Porsche cars that I have, or Porsche vehicles that I have are cars, I can use the as with the exclamation point to say, okay, I know that those are cars, I want to use them as cars as well. In this case, the cars here properties or variables not an optional because I'm specifying this is of that type. It will be a car, or here an array of cars in that case. So again, for that case, you need to be certain that it actually is all cars within that in that array, and otherwise, it will crash again. Yes.
At the point of casting, or if I try to access the property that doesn't exist on
I think it will crash at this point. That- It will crash as soon as you try to cast something that is not, trying here to cast it as an array of cars. So if that doesn't work, if that casting doesn't work, it will crash at that point. Unless I'm not really mistaken, because it always checks really the types that it works. So after this point, cars will have those, will be an array of cars. And if it doesn't work at that point, during the execution it will crash. All right, but what if I want to work with different types directly? And in tuple, for example, what you can use is the any type, and any can really be anything at that point. Can be a string, double, can be function, can be class, can be struct, really, anything. So if we have here an array with the type any, can be integers in there, can be strings, whatever. And then if I access these values and I want to actually work with what is in there, then I need to cast them to, for example, here, use it as in an addition, that I can use the 5 actually as an integer. So that is for really anything, but there's also the any object type that is then specific for classes. So that can't be a struct, but needs to be from a class. All right, so so far about casting then. Guard is also another keyword and structure that you will see quite often in Swift. And what the guard command does is similar to the if statements and the structure there, but the other way around. So let's look at that from an example. So we have our function here to sing happy birthday. And for that, we need to make sure that a couple of conditions are met. So first, I need to check whether today actually is the birthday. Yes, and if that works, then we're checking whether there are invited guests larger than 0, or the number of invited guests is larger than 0. If that is true, then we'll check whether the candles are lit on the cake, and if all of that is satisfied, then we sing or can sing happy birthday. But now we need to also handle what if those conditions were not met. So first is for the candles. So the candles haven't been lit, is then the output. Then the next else is, okay, the invited or number of invited guests is not bigger than 0, so just a family party. And if the birthday is not, then no one has a birthday today. So, and what you see there is that the handling of what is, if it's not true, is far away from where actually checking this condition to this. And that is where the guard statement turns that a little bit around. So because for guard, you have the guard keyword, then you have the condition, and directly after that you going into an else block where you specify something that should happen if the condition is not met. And within this else clause, you need to have a keyword that's breaking the current scope. So I need to have a return, continue, breaking, or throwing an exception over. I think those are all of them. Something that is actually breaking here the context. And then afterwards, that is what happens if the condition is true. So looking here at this example, what would happen if we use guard for that is we first check, is the birthday today? And if that's not the case, okay, no one has their birthday today. We don't need to worry anymore or more about what's coming after. We're returning at this point, and we're done. If we reach this point, then we know that birthday is today is actually or was actually true, and we check for the invited guest. And again, if that is not the number of invited guests is not bigger than 0, then it's just a family party. And we return because we don't sing happy birthday at this point. Similar for the cake and candles. And if all of that, all these conditions were true, then we print out happy birthday. Yes?
Is there a difference to if not?
Yes. Because for if not, you could continue with that. For guard, you are forced to execute the scope or exit the scope within the else block.
You have to return.
And if not?
In the guard.
Yes. Return, break, continue, or I think throwing an exception are the keywords. So go on to the next slide, then maybe makes a little bit more sense the difference to if not checking that. Because so if we have go back to the if statements and if let working with optionals, if let trying to assign x to whether the goose has laid eggs, that is an optional. I'm trying to assign it to this. If that's true, then I'm printing out the number of eggs. After this this bracket, then x I can't use it anymore because it was only defined within this scope. For the guard statement, that is something. If I am after the guard statement, I know that this property has been set, or this optional was set and is now unwrapped. So if I have guard and have the let x equals the goose x, if that doesn't work, then I'm returning. I don't care anymore, or I know that the x were not set. But after that, then I can access the x.count or the x variable that I have set. So at this point, I am sure that the optional was set, and I can continue working with that. And that makes the interaction with a lot of optionals quite handy, because if I use the if-let way, I'm always adding another layer, another scope that I am defining my variables in, and outside of those I can't access those. But for the with the guard statement, after the guard, I can be sure, okay, this has been set, and I'm still on the same level as the guard statement. So if you're thinking about indentations for the if-let, you indenting way further, guard stays on the same level. Does that make then a little bit more sense for the difference? Okay. And similar to if-let, you can also unwrap multiple optionals in one guard statement. So trying to have a book, trying to unwrap this title, the price, the pages. If that all doesn't work, then I'm returning. And after that, I know at this point this condition was met, so I have assigned all my optionals. All right, any questions about guards? Yes.
When you unwrap something, can you add to that expression? Like, could you say guard let title equals title, or something completely different?
That you give a default value if that doesn't work, you mean?
No, that you just say, or something else is true.
No, because it tries to assign this here. So with this statement, it tries to assign this. I can't now overwrite this and say, otherwise, if this works, let that be true. For that, you need to structure it more clearly, that first you try to assign it, and if that doesn't work, then I do something else. I mean, you can, if you try to assign here just the title, or here the X, within this code block, before you return, you can do some other things that, for example, print out, this didn't work, or error message, or message somewhere else, and then return after that. So reacting to it doesn't work to assign it. But this is both if let and guard are really to make sure, okay, this has been set within my code block. I know that the variable is now unwrapped and I can work with that type. Okay. Briefly, also, let's talk about enumerations, because they're also something within Swift that are very often used. And enumerations are essentially defining certain values that a parameter can take. So, for example, for an enumeration compass point, I'm defining the cases that a compass point can have. So north, east, south, and west. If I want to have more values, kind of northeast, north, south, and whatever. North, south doesn't make sense. Northwest. But yeah, in this case, we only specify the 4 main compass directions. And whether I do it individually, case, or have just one case and separate them by commas, doesn't really make a difference here. And what this allows us now to do is to use the compass point with these specified cases that I can set. So for example, I have a variable compass heading, and I set it to compass point .west, because that is one of the specified cases that a compass point can have. And if we have another heading and specify that it is of type compass point, I don't even need to specify compass point .west. I can only use .west. That would work as well. And if I change this variable, again, I only need to specify, okay, it's .north. Because those are the cases that we've defined for this enumeration. And what that allows us to do is, for example, to use a switch statement to react to these different cases. So if we have a switch over the compass heading, can specify a case for north, east, south, and west individually, and then react to those. So since I know that a compass point only has or can be one of these 4 cases, I don't, for example, don't need a default statement here, because we know this switch statement is exhaustive. Every case that the compass heading could have is dealt with here. So where does this also make sense, or even more sense, is again for the type safety. And the example here, if we have a movie and the movie should have a name, release year, and a genre, if we just use for genre the string, of course I can write in something that makes sense, that Finding Dory is an animated movie, but I can also write something, enter a string that doesn't make sense. So in this case, I can't really be sure that what I have inside of my genre string is something that I can actually work with. On the other hand, if I define an enumeration, name a genre, and have all these different cases for animated, action, biography, whatever, and use that as the type of the genre, then I can specify it is .animated, and I know it will only be one of those. So it's not possible that there's a genre edit that that doesn't exist, for example. Question about enumerations that came up. Yes?
Is it possible to cast all the values to an enum, like for example an integer, and get returned the first enum which is defined?
Oh, you mean the first case that is set there? Interesting. I know that internally, I think they're numbered. I think so, that you can access with .0 would be the animated case. Oli, do you have your, no. René, do you have currently a code open that you can try, well, if you have an enumeration, if you can access this with .1 or .0, whether that works? Wondering if I mix it up with tuples as well. Because in tuples, that works for the element in there. But for enums, since it internally works, could work, but I'm not sure. Let's see. Okay, then appears to not work. Then probably they're internally numbered, but yeah, not outside because it would not confirm to the name that it makes sense that you, when you read it, know what case was assigned to it.
Like raw values. There was something with raw.
Yeah, not sure.
I'm not sure about the company one, but I think we had some instances where we had like raw ways and then you could access with 0, 1.
That you can ask for the animated.raw value probably. Yeah, that.
Something along those lines.
Yeah, it is something. It is internally working with numbers, and I think you can access them as well. At least from what value does this have, but I'm not sure whether you can reverse it with the raw value, get to the as a setting way. Because I also would not be sure in what case that would make sense. Yeah, a helpful thing for this is, for example, if you in Xcode use an enumeration, once I have here the genre and I just type in the dot, I get the auto-completion with all the cases that are met there. So I can select those out. Automatically going through that numbered might make sense to, if you want to print out all the different possibilities that you have. But yeah, I'm not sure. Yes. Okay. Yes.
It's possible to give a raw value for enum, and then you can instantiate that using that value.
Mm-hmm.
For an example, I don't know, you have a user input, then you can use that to get an enum from that.
Okay. Yeah. So yeah, a couple of things you can, aside from that, work with those enums. Since underneath, yeah, they, I think they are numbered, but yeah, I'm not sure exactly how much accessible outside.
Regarding the raw value,
Yes.
something. You can basically say that the genre is of type int, for example.
Mm-hmm.
And you can say case animated equals 1 and then just continue.
Mm-hmm.
And then you can say genre.animated.raw value and then you get the 1.
Okay, yes. So that when you define the enum, that you specify from what number it should start counting. Yeah, that's something that you can do. So for example, if I here for animated or access or enter equals 0, that would be, okay, this is starting then from 0, action would be 1, Romans 2, and so on. And that is something you can work with. Not entirely sure, I haven't done that very often. So. But yeah, can take a look at the enumerations. Yes?
So you just said that enums like a number internally.
Mm-hmm.
Can you also assign like string values to the instead of numbers?
Can? Okay. I haven't done that, so I'm not sure whether it worked, but apparently it does. Where would you use that? If
I don't know, in some other languages, they would use it to make like instance of, I don't know, JSON object, there wouldn't just be number 0, 1, but some readable line.
yeah.
I would see what row is it.
Oh, so that you can reverse it into, yeah. So it seems to work. That yeah would be a use case how to access that.
Yeah, I just also checked that in the editor, if you're using string, then you can set, for example, equals and then, for example, double quote 1.
Mm-hmm.
And if you get to the raw value, you get this 1. If you don't specify anything, then it's just like the name you specified in quotations.
Okay.
String
So
value.
the name you
So it
specified in
would
code.
be like the raw value, if this was a string enum, it would be animated.
Oh, okay.
Or action. And if you say animated equals hello, then it would be, the raw value would be hello, and from the others it would still be action, romance, and so on.
Oh, so then it would default to the name you have there if you don't specify a specific.
Some kind of ordering, and with strings you often don't have that, so you need to specify it, and if not, it just takes the word and turns and just get it.
Perfect. Interesting. Also learned something. All right. So far about the Swift portion of the class. Now we'll move over to a demo about segues, navigation controllers, and if the time allows, also tab bar controllers. I'll quickly switch over. So let's start. So the project that I've set up here, I will zoom in from time to time to show you the main parts. The code should already size-wise be readable from the back. Does it work? Okay. But yeah, we'll spend most of the time in the storyboard here. So far, when you work with the storyboard, we only work with one screen that we have. Question is now, if we have multiple screens, how do we navigate between them and transition there to new screens? So if we want to have another screen there, let's set more readable. So if we want to add a new view, we also need a view controller for that. If we add this view controller to our storyboard, this will be fun. Then we have here our two screens. So to differentiate between them, I will give them different backgrounds. So let's start with red for that one and yellow for that one. So here then we have two screens, and I want to start on the red one and transition over to the yellow one. And we want to transition if I press a button. So what I've now set up here, I have entered a button to our red view controller. And to specify that when I'm pressing that button, I want to move over to the yellow view controller, what I can do is just right-click and drag from the button to the other view controller. So if I right-click and drag, I have this line attached to that. If I drag it to the new view controller, it specifies, okay, what sort of segue do I want? Segue is transition essentially to another view controller. And here we have show detail, that way. Show detail, present modally, or custom ones, or older ones. The show segue is something that then dependent on the context that I'm calling this in. It then uses a transition that fits to that context. So if I select show, we have now this connection segue between our view controllers, and you can also see the yellow view controller is not completely full screen anymore. There is some overlay that I have there. And if I select this segue, can also see that I have here different properties that I can specify. Most importantly, an identifier that I can use in code to identify our different segues. And also, what sort of segue do we want? Again, I can set it here, whether it's show or present modally. So in this context now, it directly has this overlaying of the yellow view controller over our red view controller. So if I run this, we now have our red view controller with our button, and if I press on that button, the yellow view controller slides over that. And that is the modal transition. And to go back to the red view controller, I just drag this down and I transition back to our red view controller. And of course, we can do that with multiple ones. If I add here a green view controller and then do the same thing, adding a button to our yellow one. And again, right-click and dragging to the new screen that I want to use creates this segue that I'm using. And this would, again, over the yellow view controller, overlay then our green one. Now the question is, how do I get back from the green view controller to our red view controller in one go. Because at the moment, I would need to swipe down multiple times since I first go back to the yellow view controller and then to the red view controller. So if I want to have a button here where I'm going back to red, not that. Yeah, that's all right. So if I would go, yes?
I didn't want to interrupt.
No.
Okay, maybe it could be a quite silly question, but I'm not really sure, like, what is the purpose of it? It's just like for planning an app and then it's easier to realize it, or does this maybe, because there are also some tools that, I don't know if you know, for example, WordPress Elementor that creates simultaneously code. Is this like creating code, or is just like planning an app and then you can realize it? Or?
This is the storyboard way of planning your app. So this is not just or layouting your app. It's not just for planning. This is actually the interface that your app is using. Next lecture, you will also see how do I define for different screen sizes and orientations, how to handle those. What you're mentioning is more the Swift UI way that we'll talk about the end of the class, where I specify my whole UI in code, and it is then interpreted. I can also, without using the storyboard, set everything up in code within my view controller classes. Where do I add a button and add the constraint there? It's quite a hassle to do all of that in code. On the other hand, if you work with multiple people and versioning control, sometimes it's the better way, because this is creating an XML file that is changing every time I just move the camera. So using that in a version control is not fun. Okay, so if we want to go back to our red view controller directly from the green one, if I would just create a segue, so right-clicking from here to the red one, that would not work, because it would just add another view controller on top of each other. So just quickly to demo that, if I create this segue and I let everything run. So now we have our red one. I click on the button going to the yellow view controller, click on the button going to the green one. If I now click on red, it adds another one on top. So it's not the original one that we were using. So how do we do that? Let's remove that segue. For that, what you can use is an unwind segue. And an unwind segue is just in your view controller specifying, okay, this is a location that you can navigate to. So in our setup here with these three screens, we would specify for our red view controller, okay, this is a point I can go back to. So within our view controller class that is set to the red view controller, I'm creating now an IB action for this unwind segue. Why does it need to be an IB action? I want to use it also within the storyboard, that the storyboard knows about this function, that I can refer to it there, and I can use it there. So unwind to red. So the name is there not really important for the or the name of the unwind segue is not important. The important part is that your function takes a parameter of UI storyboard segue. That is all that is needed for this unwind segue to specify, okay, this is a point that you can navigate back to. So what we then do now is within, let's zoom in, we have here our green view controller, and when I'm pressing this button, I want to go back to our red one. And how we do that is by using this exit location that we have here. So if I, again, right-click or right-click drag to the, let's get there, exit, there within the completion, we get our unwind to red segue that we just specified. And that is why it is specified as an IB action, so that it actually shows up here. So now if we set that and let everything run, and move over to our green view controller. Now if we press go to red, we actually go back to the initial one that we've used. So that is a way to structure the navigation through your screens. But yeah, it's again something that you there's a lot you're doing manually, and there's often the case that you have a set of screens that you want to iterate through, so drilling deeper. Think of the settings, for example, where you have a list of properties, and for each element I want to go one step deeper to specify those and be able to directly go back. So to make that simpler, you can use a navigation controller. So a navigation controller is something that provides a lot of these functionalities directly that you don't need to specify it manually. Okay, want to transition from this element or this screen to another, and also need a way to get back. So how do we use navigation controllers? Simple. If I select my initial view controller that I want to start with, and here in the bottom right of the interface builder, I have this embed in window, and there I can select to embed this view controller in a navigation controller. And once I do that, here a new navigation controller is added in front of that, and we can directly see that here our yellow and green view controllers have now a back button directly added to that. So that is because they are inside this navigation controller that we just set up. And navigation controller also directly has, interesting, this this bar button that is added to the navigation bar that is added on top of your screen, where you can specify a lot of general appearances for this navigation bar that's carrying over through all the screens that are following that here. So whether it's a large title that should be used, or just the general appearance in terms of color and whatever. So what's also directly then added to each of the view controllers is a navigation item. So that this navigation item can hold, for example, the title. So if we add here for the title of our red navigation controller or view controller the label red, oh yeah, can't see that quite easily. That is then shown there on the screen, and also on our yellow view controller, the back button also directly changed the label. So now it's that it is going back to the red one and not simply a back. And we could also specify that even more. So here, if we have the back button property that I can set to maybe go back to red. If I specify that, then on our yellow view controller, it would also directly use that. So can use those here directly. Similar for the yellow and green view controller that we specified those here. And within this navigation item, I can also add more buttons or more elements. So bar button item. I can drag that inside here in this navigation bar, and such an item can use specified styles that or settings that we can use. So, for example, for an ad, would directly use it as a plus sign, saving, or whatever. So there are a couple of predefined values that we can use, or just use a custom one and add your title or whatever you want here. So, and if we want to use this one as our button that is going back to our red view controller, it's the same of just dragging from here and using our unwind segue, and that would then be connected, that I can use this here. All right. Since we set a title here for everything, like I said, if I say this should look like a or use large titles, then it would change the appearance for all the view controllers that are following. But for each of those, I can specify whether that is something this setting should carry over from the previous one, or here, if I say, okay, this should never be a large title, then we'll go back to the original one, and also all the those are following will also then return to the small title. But yeah, let's use the big one. What else do we have? Okay. So this is now only for transitioning from one screen to the other, but very often you also want to pass information between them. So that for the red view controller, I want to pass over information to the yellow one. So to demo that, let's add a text field to our red view controller, and the goal is that whatever I'm entering into this text field should be the title here of our next view controller. So that where we want to pass over content from this view controller to the next one. So if we want to access this text field, I need to have an outlet in our view controller. And in this case, having Xcode on a small screen is a lot of fun. So to create an outlet, I right-click, drag into our code, and just specify, okay, I want to have an outlet of the type UI text field. And that way, they're directly connected. So now I have a way to access the content from our text field. And what every view controller has is a function that is called before a segue or transition is executed. And so that method is called prepare for segue. And with that, I get also the segue as a parameter, so I can work with that. So since it's a function that already exists, override prepare for segue. So here I have a storyboard segue as a parameter and a sender that is calling for this segue. And so what I can do is with this UI storyboard segue parameter, I can access the properties of this segue. And the most interesting ones are the identifier. If I specify an identifier for this segue, so I know which one is called. But also the source and the destination of the segue. I know, okay, where I'm starting from and where am I going. So if we want to set the title for the following view controller, I need to go to the destination, access there the navigation item, and set the title for this. So what we're doing is we're taking the segue, there I get the destination. Destination has a navigation item that is set, and navigation item has a title. Those are directly for each view controller has this element. And inside of that, I want to set the title to the text in our text field. So that is everything from this side. So now I have here a text field in our view controller, and if I just add iOS class here, and now I'm transitioning, then you can see that the title changed to the iOS class. So use the prepare for segue method to carry over properties or values to the next one. Okay, yeah, so far we've we've always specified the segues in our storyboard and also specified for the button, if I press this button, then this segue should be called. But what we can also do is specify and trigger segues from code. So quickly just remove these elements that we don't need anymore. Going back to the storyboard. Don't need the a little bit of a cleanup. Okay, so say we want to, for a red view controller, trigger segues either to the yellow one or the green view controller, depending on whether a switch is set and which button I've pressed. So here we currently have one button. Let's just switch that to yellow and add another, or use another button for green. So each of those should go to the corresponding view controllers, but only if this switch that we've added is active. And so now instead of creating the segues directly from the buttons, I will do that from the view controller itself. So having one segue here. Giving it the identifier yellow. And another one for green. And now I want to go from within the code. Once either of these buttons has been pressed, I want to trigger the segue with the specific identifier. So for both of these, I need first an outlet for our switch. So let's call that segue switch. And for our buttons, creating a function that's just triggered if the button has been pressed. So button pressed. And let's zoom in. Of the type that I get for our sender, I'm specifying that it is a UI button, so that I can directly be aware of, okay, this is a button that was calling this. So this was first set for our yellow button, and I will also connect the green button to the same function. So what this setup now means is either button is pressed, I'm calling the same method, our button pressed method. And within that method here, I now first want to check whether the switch is activated. If the switch is active, then I want to carry out a segue. If that switch is deactivated, yeah, I'm not doing anything. So first I need to check on the state of the switch. And then I need to trigger the appropriate segue for the button that was pressed. So first, if segue switch is on, if that is set, that is the first condition that I'm checking. But I'm also combining this with trying to unwrap the title of the button that I'm using. So for the buttons, we set them to yellow and green. So I can use those since I also named the segues with the same titles. So I'm trying to unwrap that optional. And since I have from my sender, I know that is a UI button getting the title label and the text. You can see that Xcode directly added here the question mark because the title might not be set. So if all that is true and I was able to set the button title, then I want to now trigger the segue. And the method is for that is called performed segue with a specific identifier. So since we set the identifier to yellow and green, which is also our button titles, I can simply specify that I use button title as the identifier, and since we don't care for the sender, set it to nil. So, and with that, our code should work. So, is it good? So, we have that way. Our view controller, now if the switch is deactivated, I can press these buttons and nothing's happening. But if I activate it and I press yellow, I'm going to the yellow view controller, and if I press green, I'm going to the green view controller. So that is a way where you trigger specific segues from codeout. Of course, again, this is not the best style, using the button titles as the identifiers as well. Best to have their more clearer names or more structured way of doing that, but to show how to check something before carrying out a segue or whether a segue should be triggered, this example shows how that works. So yeah, this is an example how to trigger the segue also from code. Similar way to for this example, another way to do that, and one that is probably a little bit better style-wise, is there is also a method should perform segue with identifier, where that is called before a segue is carried out, and with that I can check whether that should happen and also cancel it at that point. So if I have my segues in the storyboard set up directly by dragging from the buttons, if I then press the button, I could check and prevent the transition based on the switch as well. So that would also work. But yeah, carrying out or triggering a segue using this perform segue with identifier method. Any questions so far about segues, navigation controllers that we've? Yes.
What's the life cycle of the segue look like? Does it get destroyed after you open another one, or does it just get paused?
The segue is complete when you moved over to the next view controller in that. So you could trigger it again if you go back, but it will always create a new one. It's not something that, this keeps the state or whatever. So this is more the transitioning over, and then I'm in the next view controller. All right. So if we look at different apps that you see on a phone, navigation controller is one thing that is often used, for example, in the settings, where I go deeper into different levels and can go back. But another thing that is that you can see very often is that you have multiple elements here on the bottom of your screen, and they are not really that one screen is belonging to another controller, so it's not really a second level of our settings, for example, but they're existing more side by side. And that is what's called a TEPA controller, or is realized with a TEPA controller. Let me quickly clean up the code here again. And if we go back to the storyboard, also remove everything here. And also remove our navigation controller. So now, if we always had the case, okay, we're starting on our red view controller, and from there on, we're moving to different view controllers. But if we want to have all of these red, yellow, and green essentially being their own starting points for different parts of our app, then a TEPA controller could make sense. So similar to the navigation controller, what we can do is with the red view controller here selected, click on embed in, and there we have the TEPA controller also underneath the navigation controller. And if we set this up, then we have here our TEPA controller that directly has here an item that is connected to our red view controller. And similarly on our red view controller, we also on the bottom directly have an item visible there. And if we want to add multiple view controllers to this, similar to creating a segue or transition, I can right-click drag from our TEPA controller now to our yellow view controller. And apart from the segues, you can also see here a relationship segue for the view controllers. And this view controllers is the various view controllers that this tab view controller can move to. So if I now add this here, you can see that directly our TEPA controller, now we have two items here. And same for the green one. If we add it here, then we have three levels there. And that is everything that is needed to set up this general TEPA controller. So if we run this, we again start on our red view controller, but probably can't see that on the screen. There are buttons down here that I can use to switch between these different view controllers. And different to having segues between them, they are all full screen, don't have a tab bar or a navigation bar necessary there on top. It's really, okay, this is now the starting point for something that's starting on the green view controller. I could embed the green view controller in the navigation controllers and navigate down from here again. But now the overall top level is here our tab view controller. And similar to the navigation bars and the bar items there, I can specify the different properties of our item that we have here. So on the yellow one, for example, I can set it to yellow and specify that the image there are a lot of images that are directly available in Xcode. So if we want to have a square with a letter Y in there, and for the selected one, want to have the same but filled, this will update our the tab bar items here directly. So same for the red one. Let's not move a selected one, or and here green. Different zoom levels. So, and that is then accessing the items here directly. And you can see the selected items, of course, image is called or shown when I'm on that specific view controller there. And yeah, other properties that we have here are, for example, a badge value. So if I just add a 3 there, that will automatically then add a value there. And we can also do that via code, so that we can show from one screen, maybe there's something that we need to take care of or should look at on another screen. So how we could do that from code is accessing here in view.load if we want to just set a batch item there. So get to the tab bar item and set the batch value to something. Doesn't need to be a number, can also be yeah, a string that I'm adding there. And if we want to remove that, for example, if we switch over to another one of our view controllers, we can do that in the view will disappear, for example. So that is called when I'm moving over to a new view controller or I'm switching that, this function will be called, and there I can then again access the batch value and just now set it to nil. And that will remove the batch that we have on there. So if we start this up, you can see that from starting there I have my a batch beside my item, and if I move over to a new one, that disappears here. Something that is also yeah, helpful, or a helpful feature of the tab bar controller, you can add multiple view controllers. They will directly show up here in the tab bar to switch between them. But automatically, if you add more than, I think, 6, not sure exactly, 6 or 7, if I add then more view controllers to this, it will automatically add a more button there, and the other view controllers are then shown in new tab that I can switch between those. So it's not that the bottom space is getting too small and too crowded to click on. And with this more option, you automatically also get a reordering of that, so that the user can move those items around and move the order of the red, or yellow, or green view controller and change the orders of those. Yes. Okay. So that was also now about the tab view controllers. Any questions about that? All right, then let's quickly move over to the slides. So yeah, segues, navigation controllers, and tab bar controllers that we talked about. And other than that, yeah, today spoke about optionals, guard, and enumerations on the Swift side. So how to create properties that can also be nil and how to work with those. Typecasting and inspection, how to check whether a variables of a specific type cast it to that and react to those. And then in the end, on the UI kit side, looked a little bit more about how do we transition between different views, different view controllers that we have, and how can we use navigation controller and tab controller for that. And tomorrow you will be looking more on view controllers at auto layout. So how do we specify our user interface so that it reacts to rotation of the device, or that I can lay it out for different screen sizes and it looks quite well. And on the Swift side, protocols and extensions will then be the main focus there.
This content was provided by RWTH Aachen University.